This is video on statics of coplanar non-concurrent forces. The first video, it deals with basics. Now, if you look at the overall scenario or the bird's eye view of study of statics, it looks like this. Two parts, concurrent forces and non-concurrent forces. And in concurrent forces, we have to learn how to find resultant and solve equilibrium problems. And similarly, in non-concurrent forces also, there are two parts, finding resultant and equilibrium. Now, this video deals with statics, non-concurrent forces, basics of how to find resultant. Later on, of course, we'll look at equilibrium problems and then applications, so like beams, trusses, frames, etc. Now, in order to study how to find resultant of non-concurrent system, let's take some non-concurrent system in plane which consists of 4 forces and 3 couples. These forces are all spread out, so they are surely not concurrent, and couples are also all over. Alright, so how do I tackle it? The way suggested is convert this scattered force system into a concurrent force system. How do I do that? Bring them to origin, bring all these forces to origin and bring all the moments to origin. How to do it, we'll see. But suppose we are able to do it. Then system reduces down to 4 concurrent forces, of which you know that you can find resultant and come up with one force acting at origin, and moments or the couples being in plane, they are either clockwise or anti-clockwise. If we bring them down to origin, what we find is we'll left with single couple which will be either clockwise or anti-clockwise. So the crux of the matter is the resultant of non-concurrent force system consists of one force and one moment. And broadly the method will go like this, but then what is important is we must know how to transfer force from one point to other and how to transfer couple from one point to other, because if we can do that, then it is as good as handling concurrent system. So let's take slight deviation and learn first how to transfer a force from one point to other. So for that purpose, what we have done is taken a body shown here, and on its left corner 10 Newton is acting downward, and my objective is to take this 10 on the other corner. I want to move this 10. So what I have done is I redrawn the body, and because I want to move this 10 on the right corner, I have drawn 10 there, but then I immediately drawn 10 in opposite direction. Now I think everyone will agree that figure 1 and figure 2 are like statically equivalent, because though I have put the 10 Newton on the right top corner, I put 10 Newton in opposite direction also. Now I simply want to point out these two tens. They are equal, they are opposite, they are parallel, and they are separated by distance. So what they do? They form a couple. See, the net force given out by these two forces is 0, but these two forces together do give me 10 into 2, 20 Newton meter anti-clockwise moment. So the third figure, I simply show the effect of these two forces. Now have a look at figure 1 and figure 3. See what has happened. 10 Newton, which was on the left top corner, has moved to right top corner. But what we must do, remember, as we have demonstrated just now, is while doing so, you just can't take and put it there. You have to add a moment 20 Newton meter. And what is that? That is the moment of this 10 Newton force about this point, 10 into 220. So this we have to add. As long as we add that, transfer of this 10 from here to the other corner here or here is successful. So what we learn from this simple demonstration is to move the force. After moving the force, you have to add a movement at the new point. Now this information is going to come very handy in our further work. Since this is going to be crucial, here we are going to do some examples of transferring forces and moments. So let's say I have on this top corner, this is a grid, okay, grid of 1 unit by 1 unit, so all the distances are 1. On the left top I have 10 and Newton downward and 20 Newton towards my right and a 30 Newton meter moment, and my intention is to transfer all these forces here. So from the method which was just suggested, take this 10 and put it here, take this 20 and put it here, but remember that each transfer I must add a moment. So if 10's moment about this point is 10 into 4, 40 anti-clockwise, 20's moment about this point is 20 into 2, 40 clockwise. If I sum them up, they get cancelled, and then 30 I just pick up and put here. You see, while transferring couple from one, the couple is a free vector, so from transferring from one point to other, you don't need to do anything, you can just physically keep it there. So the net result of these three is what I see at this point, again 10, 20, 30, and this transfer is successful. Now suppose these three I want to transfer it to point below. What do? I put 10, I put 20, then I put movement of 10 about this point, 10 into this distance 1, so it's anti-clockwise 10. Then I take 20 here, so 20 into 2, 40 clockwise, so I get 40 here. Then I take this 30, so 40 plus 30, 70, but this 10 is anti-clockwise. So finally I get algebraic sum of all these three moments. Which one? This 10, this 40 and this 30 as 60 clockwise. So this is a successful transfer. Now suppose I want to take this all three and put it here. Well, very similar method. Take 20 there, take 10 there. 20, when I take it here, I don't have to add any moment, because see, this is the same line, so 20 doesn't give me any moment about this point. 10 does give 10 into 3. This 30 gets added to 60 to make it 90. So this is a successful transfer. Now finally, suppose I want to take this here. So I again take 10 there, 20 there, keep track of moments, 10 into 2, 20 clockwise, 20 into 1 anti-clockwise, 20, 20 get cancelled, and I get again 10, 20, 90. And let's say I want to put this back here. Well, I better get 30, and we do that because 10 gets transferred straight away. 20 into 360, 90 minus 60 is 30, and you recover your original forces. So this is a thing, this is a fundamental principle which we will be using all the while studying of the non-concurrent forces. So in this basic video, it was very important to learn this. We'll continue with this more study on these in the next videos. Thank you.